Hello students, welcome to the School of Science and Art. I'm here to help you understand the basic concepts of physics in a simple manner. I'm also available to answer your questions, which you can add in the comment section or simply email to me at yvsridhar@gmail.com. This is your first physics class. We are starting with kinematics, which is the branch of physics concerned with the motion of objects. Let's get going. One of the key things studied by physics is motion. Motion is everywhere. Motion of planets, the moon and the stars, Earth's rotation on its axis and its revolution around the sun, motion of a bouncing ball, motion of blood in arteries, motion of a train, motion of an airplane, motion of water in a pipe. Now remember, everything around us, including each one of us, is moving one way or the other. Even seemingly stationary objects could be moving. For example, even if I'm sitting idle on this couch, I'm moving along with the earth around the sun. We define straight line motion as, well, motion that is along a straight line. It could be in the vertical direction, horizontal or slanted, but it should be along a straight line. Let's look at an example. Here you see something that's usually called an inclined plane, a wedge, or just a triangular block. Imagine that we are looking at the side view of one such block, and as you can see, this view is a right-angled triangle. It is placed on the horizontal surface along one of its faces. Let's call it OB. Of the remaining two faces, OA and AB, we can see that OA is perpendicular to the ground and the other face AB is a surface inclined with respect to the ground. The face AB, which is the surface inclined with respect to the ground, thus provides an inclined surface on which objects can slide or roll. Let's say the angle of inclination of AB with respect to the horizontal is theta. If we place an object, say a rectangular block, on the inclined surface AB, we expect this block to slide down along the surface AB. Why does it do that? From our experience, we can tell that it slides by virtue of its weight. So the block slides down and hits the ball at the bottom of the incline, and the ball rolls off because of the impact. For motion to be considered as straight line motion, our object should either be a particle, which is a point-like object like an electron, or an object that moves like a particle, that is, every portion moves in the same direction at the same rate. Therefore, the rectangular block fits into our definition of an object moving in a straight line. But the ball that it hit at the bottom of the inclined surface and which rolled further along the floor does not fit into our definition of an object moving in a straight line. That is because all points in the ball are not moving in the same direction and at the same rate. Why? Since the ball is rolling. Although we do notice that the resultant motion of the ball is in a straight line, that is, along the horizontal surface and towards the right, different points on the ball are undergoing a mix of circular and linear motion. In straight line motion, therefore, we'll be dealing with objects moving like the block here, and not those moving like the ball. Rolling and rotational motions will be handled in a different topic. A common and very good practice to observe motion and position of objects in physics is to locate an object by defining a reference point, that is, an origin, and a set of coordinate axes, that is, the x, y, and z axis, around the object. Now, these carefully defined origin and coordinate axes, based on which all observations and measurements would be made, are collectively called a reference frame. In this example, we have chosen the point O as the origin and the x and y axis along the horizontal and vertical directions as shown. The fact that angle AOB is a right angle has also made it convenient to place our origin at O and align x and y axis along the sides of the triangle. Now let's reiterate. To analyze motion, we should always define an origin and a set of coordinate axes, that is the x, y, and z around the object. As we know, the positive direction of these axes is the direction of increasing numbers or coordinates, and the opposite is the negative direction. The units for the coordinate axis should be chosen appropriately based on the size and scale of motion we want to measure. The position of the object is its coordinates with respect to the assumed origin and axis. For example, the object shown here moves from point A to point B. We can say that the initial position of the object was at A, which has the coordinates x equal to -5 meter and y equal to 4.5 meter. The final position of the object is at B, which has the coordinates x equal to 3 meter and y equal to 4.5 meter. We assumed that each unit along the coordinate axis is of length equal to 1 meter. The displacement of a moving object is calculated as the straight line distance between the initial position and the final position over a certain time interval. Also, please note that displacement is defined as a vector quantity, which means that its value needs to go along with its direction. So, for the object here that moved from A to B, the value of displacement is the length of the line segment AB. Since the object moved only in the horizontal, that is x direction, the displacement is given by the difference in the x coordinates of B and A, which is 3 minus -5, that is equal to 8 meters, assuming the lengths are all in meters. And since displacement is a vector, we should always remember to talk about the direction of displacement, which is from A to B in this case, usually indicated graphically by drawing an arrow from A to B as shown. Let us look at another example to understand displacement. A man moves from point A to point B along the path shown as the dotted line. As we can see, this is not a straight line motion. We are using this example just to understand displacement. The length of the actual path walked by the man to reach B from A is 80 meter, which we can also call as the total distance covered. The displacement, however, is the straight line distance between A and B, which is 50 meter, and the direction of displacement is from A to B along AB. So to summarize again, the total distance covered is the length of the actual path taken by the body from its initial position to the final position. Distance covered being a scalar quantity, we are not talking about direction here. The displacement, on the other hand, is the straight line distance between the initial position and the final position. Its direction, since it's a vector, is from the point of initial position to the point of the final position, shown graphically through an arrow. For an object moving in only one direction along a straight line, the distance it covers is equal in value to the displacement. For an object moving in a straight line, it is often convenient to orient our coordinate axis such that one of the axes is oriented along the line of motion. We generally choose this to be the x-axis. This makes it simple for us to locate a moving point in terms of the coordinates, and it also makes calculations easy. As shown in this image, the object moves from point A to point B. We align the x-axis along AB and place the origin at A. The motion, therefore, is purely along the x-axis. The displacement of the object is 4 meters along the positive x-axis from A to B. Let's say the object covers this distance in 5 seconds. We define the average velocity of the object as the displacement of the object per unit time. In other words, average velocity, V average, is displacement delta x divided by the time interval delta t during which the displacement occurs. A common unit for V average or average velocity is meter per second. You may see other units in the problems, but they are always in the form of length upon time. We know that displacement is a vector. Similarly, velocity is also a vector, and its direction is the same as that of displacement. Let's go through an example. An object moves from point A to point B via point C. That is, it first moves from A to C along the x-axis and then from C to B in the vertical direction. It takes 5 seconds to complete this journey. The magnitude of the displacement vector for this journey is given by the straight line distance from A to B. The average velocity for this journey is the displacement divided by the total time taken, which is 5 seconds. Please note that the direction of both the displacement vector and the average velocity vector is the same and is from A to B along AB. The total or actual distance covered by this object is the length of the actual path taken by the object, which is the sum of the distance between A and C and the distance between C and B. We define the average speed of the object as the distance covered by the object per unit time. That is, you simply divide the total distance covered by the object by the total time taken to cover that distance. Average speed is a scalar quantity, as is the total distance covered, and therefore does not have a direction associated with it. Well, that's all we have for this session. I hope you found this class useful. We'll continue in the next session to talk more about velocity, acceleration, vectors, and a lot more. We are the School of Science and Art. Here's the link to our Facebook page, and you also have my email ID. Do reach out in case you have any comments or suggestions, and of course if you have any queries, I'd be happy to help. Enjoy learning physics. Thank you.